Hello everyone, thanks for tuning in. In today's session, we're doing examination style worked examples, examination style questions on coordinates and lines. My name is Arnold Rangakuramia and this is Kisembo Academy. So we'll get started with the first number. Find the equation of the line that is passing through this point, the point 0, 5, and is parallel to the line 3x minus y is equal to 7. So this is the line. It's passing through point 0, 5, but this line is parallel to the line. It's parallel to another line here, and this line it's parallel to is 3x minus y is equal to 7. So as a rule of thumb, parallel lines have the same gradient. That is what we should know, that when two lines are parallel, they have what we call the same gradient. So if they're having the same gradient, what's the gradient of this blue line? Now, to find the gradient of this blue line, we need to rearrange this equation in the form of y is equal to mx plus c, because we know that m is the gradient. The equation of this blue line is not yet arranged in that form, so it's hard for us to tell the gradient. So let's go on. First of all, the line is 3x minus y is equal to 7. So I am going to make y the subject of the formula so that we arrange it in this form, y is equal to mx plus c. So this is what I'll do. Let me get this 3x. Let me throw it that side. This becomes negative y is equal to 7 minus 3x. Let me remove that negative from y by multiply times negative 1 on both sides. This negative 1 affects everything here. So negative 1 times negative y gives us y is going to be equal to, this turns into 3x minus 7. So from here you are able to see that this equation is in that form of y is equal to mx plus c. And we know that in that form, the value of m is the gradient. So when it comes to the blue line, it means that the gradient is 3. So if the gradient of this line here is 3, it means that the gradient of that other line we are looking for here is also 3. So we know that the gradient here is 3. The gradients are the same since they are parallel lines. So they are asking us to find the equation of the line that is passing through that point. So already this other line, we have the gradient and also we have 1 point. So how do we find the equation of this line? To find the equation of that line, we shall say that we know that y is equal to mx plus c for that line that we are looking for, the black line. We have our value of m already. We know that m is going to be equal to 3 because we have 3. We have a point, we have y because it's going through point 0, 5. So if this is x and that y, we know that our value of y here is 5. And we also know that our value of x is equal to 0. So our job here is to find the value of c. So we shall come and say that y is equal to mx plus c. Our value of y here is 5 is equal to m, which is 3, times our value of x, which is 0, plus c. And then we shall end up saying that our 5 is going to be equal to 3 times 0, which is 0, plus c, which is c. So our value of c is 5. Now that we have found that our value of c is 5, so we can go ahead and write down the equation. Since our value of c is 5, therefore, from y is equal to mx plus c, our equation is y is equal to our value of m, which is the gradient, is 3x plus c. Our value of c is 5. And so from there, we've been able to answer this question, which question says that asks us to find the equation of the line passing through those point 0, 5 and is parallel to that line. Next number. Given the points 2, 4 and q, which is negative 4, 8, find the coordinates of the midpoint of the line segment PQ. So we have point P, we have point Q, and this line is moving like that. We have point P, which is 2, 4, we have point Q, which is 4,8, and we are being required to find the midpoint. For us to be able to find the midpoint, which is now Roman 1, midpoint of PQ is given by, x1 plus x2, divide that by 2, comma, y1 plus y2, divide that by 2. And so this is going to be equal to, we shall label them. Let this be our x1, that is our, the x1, y1, this is our x2, y2. So coming back here, this will become x1, which is 2, plus x2, which is 4, divide that by 2, comma, y1, which is 4, plus y2, which is 8, divide that 2 by 2. So that means that 2 plus 4 is 8 over 2, comma, 8 plus 4 is 12 over 2. So this becomes 4, 6. So 4, 6 is the midpoint of that line segment. The midpoint here is 4, 6. That's Roman 1. So Roman 2. Find the equation of the line with gradient 3 over 2 passing through the midpoint. This looks like our previous number. So we have the gradient is 3 over 2. So Roman 2. We know here that the gradient is 3 over 2. The midpoint, the point where that line is passing, is 4, 6. And now we are required to find the equation of that line. Again, we shall say y is equal to mx plus c. We have the value of m, which is the gradient. We have a point x, which is right there. We have a point y, which can be substituted there. So all we need is to find the value of c. So let's get started. So y is equal to mx plus c. What's the value of y? Y is 6, so we shall say 6 is equal to our value of m, which is the gradient, which is 3 over 2 times x, which is 4 plus c, like that. So this means that that is by 2 once, by 2 twice. 6 is going to be equal to 3 times 2. 3 times 2 is 6 plus c. So this means that 6 minus 6 is equal to c, so our value of c is 0. Now that we know that our value of c is 0, therefore what is our equation? So coming back to this expression, we shall say, meaning our equation is y is equal to m, which is 3 over 2 times x, plus c, which is 0. So even if we ignore that because the c is 0, so that is the equation of that line, and that answers Roman 2. Let's go to part B. Part B says, find the coordinates of the points of intersections of the line this and that curve. Now, when they're asking us to find the points of intersections of two algebraic expressions, in a way they're asking us to, solve them simultaneously. And this is as simple as substituting one into another so that we find the points of x and y where the two agree. So when they want us to find the coordinates of the points of intersection of this and that, of this line and that curve, it's as simple as solving them simultaneously. Let me write down here. So the thing is, this is part B of the question. So we have y minus 5x is equal to 2. And then we have the curve y is equal to 2x squared plus 5. So we have two expressions. We have a line and a curve. So what we are going to do is just substitute one into another. Already we are seeing, that is solving by substitution. So we are saying that this value of y is equal to that in this expression. So what we do, we substitute this value of y in that equation. And then we proceed with our working. So this means if y minus 5x is equal to 2, so in the place of y, let's put this, so that we eliminate y and deal with x first. So it's going to become 2x squared plus 5, minus 5x is equal to 2. So let's go ahead and find the value of x first. So this means it's going to become 2x squared plus 5 minus 5x is equal to 2. We can already see that this is having it's a quadratic equation because it has its highest power being 2. And we all know quadratic expressions are equal to 0. So let's get this 2 this way and solve the quadratic expression. So it's going to become 2x squared plus 5 minus 5x minus 2 is equal to 0. So this is going to become, again, we rearrange 2x squared minus 5x. Then we have positive 5 minus 2. What is 5 minus 2? We remain with positive 3. So that's positive 3 is equal to 0. So here we go. We have a quadratic expression. So let's go ahead and factorize it. Factorizing this quadratic expression means that we are supposed to replace this middle term. We replace it by finding two numbers. When those two numbers, when we add them, they're supposed to give us negative 5. And then when we multiply them, they're supposed to give us, a product of 3 times 2, which is 6. So when we multiply those two numbers, their product should give us 3 times 2, which is 6. Like that. So how do we get those numbers? We get those numbers by finding the products of 6. So the products of 6, we have 1 times 6, we have 2 times 3. Okay, if you look at 2 times 3, 2 times 3 gives us 6, but 2 plus 3 gives us 5. But here we have negative 5. So if we both made these ones both negative, negative 2 plus negative 3 gives us negative 5. Negative 2 times negative 3 gives us positive 6. So we shall go with this pair. And so that pair is the one that is going to replace the middle term. So this is it's going to become 2x squared. Then the middle term is replaced by this and that. So it's going to become minus 2x minus 3x. Then we continue with plus 3, giving us 0. So from there, we go ahead and factorize. So what is the common item here? It's 2x. 2x outside the brackets. 2x squared divided by 2x gives us x. Negative 2x divided by 2x gives us minus 1. Then what is the common item here? It is, negative 3. Put negative 3 outside the brackets into negative 3x divided by negative 3 gives us x. Then positive 3 divided by negative 3 gives us negative 1 is equal to 0. So from here we know that 2x minus 3, these are the terms that are outside the brackets here, in 2x minus 1 is equal to 0. So from there we know that either 2x minus 3 is equal to 0 or x minus 1 is equal to 0. It's either of those. So from here, we're able to see that x, when we make x the subject of the formula, we have our value of x as 3 over 2 or x is equal to 1. So we have two values of x. Okay, so if we have two values of x, then we can go ahead and to find the two values of y. Remember, the question requires us to find the coordinates of the point of intersection between that line and that curve. So we have two values of x. Now let's go ahead and find two values of y. We can just simply substitute in the line equation. Y minus 5x is equal to 2. So from line y minus 5x is equal to 2. Okay, let's substitute for the value of x to find the value of y here. This is going to become y minus 5 times x, which is 3 over 2, is equal to 2. So this is y, minus 15 over 2 is equal to 2. So what do we have? So meaning that y is going to be equal to 2 plus 15 over 2, which is, okay, 15 over 2. And what is our final answer here? It's 19 over 2. That's our final answer. So what does that mean? It means that when the value of x is 3 over 2, I mean the first point of intersection here is that when the value of x is 3/2, comma, our value of y is 19/2. That's the first point of intersection. Then the other point is when it is 1, when x is 1. So we shall come here and say that y is equal to, y minus 5x is equal to 2. Okay, so it is y minus 5 times x, which is 1, is equal to 2. This gives us y minus 5 is equal to 2. So y is given by 2 plus 5, that is 7. So that means that the other point of intersection is 1, 7. So by answering that question, those are the 2 points of intersection. We have this and we have that. Those are the 2 points of intersection, and by so doing, we have answered that question, that find the coordinates of the point of intersection of that line and that curve. Yep. So we have here the points 1, q and r, -1, q, yeah, and r, 2 lie on the line y is equal to 2 minus x. Find the values of q and r. So yep, we have these points. They lie on this line. They lie on the line y is equal to 2 minus x. So they want us to find the values of q and r. So what are the 2 points? We have -1, q. So we have r, 2. So here what we are going to do is that we are going to create an equation for both of these. This is x, that is y. This is x, that is y. So for the first point here, let me call it point P, let me call this point R. So for point P, let's substitute. So when x is -1, so y is q. So when the value of y here is q, it's going to be equal to 2 minus x. What is x? X is -1, like that. So what does that mean? This means that q is going to be equal to 2 minus -1. Of course, these two give us a plus. That is 2 minus x is -1. So of course, these two give us a plus. So this becomes 2 plus 1, which is 3. So the value of q is 3. Then what about in the second case when x is r? Again, we shall quote that very equation and say, okay, y is equal to 2 minus x. Okay, so when y is 2, all right, we're substituting. When y is 2 is equal to 2 minus our value of x is r. So what is r? So our value of r is, of course, well, this is going to be 2 minus 2 is equal to -r, and you'll end up with a value of r as 0. So our value of r is 0. So yeah, we have found. And finally, that q is 3 and r is 0. So let's look at part B. Part B says that in the figure below, P has 4 units. So this is the, P is 4 units from O. These are the 4 units they're talking about. The equation of the line MN is 4y plus x is equal to 12. That is MN right here, okay? All right. Find the area of OPMN. Now, when you look at OPMN, actually OPMN is a trapezium, right? It's a trapezium. So how do we find the area of a trapezium? Area of a trapezium is given by a half times the height into a plus b. Now what is the height? The height is the distance. It is the distance between the two parallel sides of the trapezium. So if you look at this, the two parallel sides, this side is parallel to that side. So the distance between the two parallel sides is that one right there, and so that is what is going to formulate our height. Okay, and we already know that our height is 4 units. So what about A and B? Actually, those sides, this is our A and that is our B. Those are the two parallel sides, A and B. So we need to find A, we need to find B, so that we're able to find the area of this trapezium. So how do we do that? Let me first clear this, and we find a way to figure out a way to do it. I'll try and drag this away so that we have space for working. Okay, now that we have created some space for working for part B, now let's say this is 0. If this is 0, it means there is 1 unit, 2 units, 3 units. All right, I've not done it so well, the spacing I mean. So let's do it this way. If this is O, so we have 1 unit, 2 units, 3 units. In other words, this is 1, 2, 3, then the 4 units. Okay, that is O. Let's call it our point 0, right? Now we're interested here. For us to find the value of A and the value of B, we need to find the distance of ON, this distance here, and then the distance of PM. So if this is 0, this is the y-axis, as you can see up here. If I may use a different, that's the y-axis, and this is the x-axis. And what do we know about all points along the y-axis? All points along the y-axis, the value of x along those points is 0. So it means that as we're moving up here, it is 0, 1, 0, 2, and so on, 0, 3. In other words, all points, all values of x along the y-axis are equal to 0. So what we have to do is, to find out that what is the value of x at this point. I mean, what's the value of y at this point? Because we know that at that point, the value of x is 0 at the y-axis, right? The value of x is 0 at that point. So what is the value of y at that point? Since we have the equation here that is connecting from that point, we shall come here and say, we shall simply say, that, let me wrap this away. So I'll come and say, we know that 4y plus x is equal to 12. But we know that at this very point, let me decongest it. We know that at this point here, we know that the value of x at that point is 0. So what is the value of y at that point? So we shall say it's going to become 4y plus the value of x, which is 0, is equal to 12. So this is 4y is equal to, 12. Divide both sides by 4. When we cancel those ones out, we will end up with your value of y as 3. You get? So that's being 3. It means that at that point n, our value, we know that the value of x is 0, the value of y we've got is 3. So if the value of y is 3, it means that this ON, this is 3 units. Because these values of y are counting from here. 1, 2, 3. You get what I mean? So, so if that's the case, then what about down here? What is PM? We need also this distance here. And now when we look at this distance here, when you look at this level here, what information do we have regarding up here, okay, at this point M? Now at this point M, we know the value of x at this point is 4, because remember this is 1, 2, 3, 4, okay? So at that point, the value of x is 4, but we do not know the value of y at that point. And the value of y at this point gives us this length from, it gives us this the length PM. So let's find the value of y. Again, we shall do the same thing. We are going to quote the formula. The formula is 4y plus x is equal to 12. And we know that at that point, we know that the value of x is 4. We are getting that from down here. So, but we do not know y. So we are coming 4y plus our value of x, which is 4, is equal to 12. So this is going to become 12 minus 4, which is 8, is equal to 4y. When you divide both sides by 4, we get our y as 2. So from here we can see that our value of y here is 2. So if the value of y here is 2, it means that this is 2 units. You get what I mean? The other side it is 3 units, there it is 2 units. So after finding those values, then we can go ahead and find the area. So it means that the area of the trapezium is going to be a half times the height, which is 4 units, into our value of A. Let's call this A, let's call this B. Our value of A is 3 units plus our value of B, which is 2 units. And then from here, that is by 2 once, by 2 twice. So this is going to become 2 times 6. And that is 12. So it is 12 square units. And that's the area of that trapezium. So that answers that question. Alright, so here again, find the equation of the line of gradient -3/5 and it's passing through point 3, 4. This is pretty familiar, a number. So gradient is -3/5 and it's passing through point 3, 4. Okay, so we know that the general equation of the line y is equal to mx plus c. So from here we know we have a gradient, so we have the value of m, we have a value of x, which is right there, we have a value of y, which is there. So let's go ahead and find the value of c. And then after finding the value of c, we shall come back and substitute it into that equation. So we start, so y, we substitute for y is 4. It's going to be equal to our value of m, which is the gradient, which is -3/5, times our value of x, which is 3, plus c. So from there, we are able to see that 3 times 3 is -9/5, plus c is equal to 4. So we can go ahead and, this becomes 4 plus 9/5 is equal to c. So what is our value of c at the end of the day? Our value of c at the end of the day is 29/5. So from there, it means our equation is going to become, from y is equal to mx plus c, it's going to be y is equal to our value of m, which is -3/5, x plus c, which we got our c as 29/5. And that is the equation of the line. Moving on, we have the lines ax plus 2y is equal to 3 and ax minus by is equal to 5, and these two lines intersect at 1, 2. Find a and b. So now if these lines are intersecting at point 1, 2, it means that the values of x and the values of y for these two lines agree. When this is a line, they agree at that point. Both lines agree at that point 1, 2. So it means when the value of x is 1 and the value of y is 2, both equations agree. So we shall say ax plus 2y is equal to 3. That's one of the equations. So, and then we have the other one, which is ax minus by is equal to 5. So let's fill in the point of intersection. The point of intersection is 1, 2. Okay, so we shall begin with the first one. So this is a times our value of x, which is 1, plus 2 times our value of y, which is 2, is equal to 3. Then let's go to the second equation. The second equation is a times our value of x, which is 1, minus b times our value of y, which is 2, is equal to 5. Okay, so now let's proceed and so here we have a times 1 is a, plus 2 times 2, which is 4, is equal to 3. Then down here we have a minus 2b is going to be 5. So from here you can see we have two equations, right? And now from those two equations, we have this one, we have this one. So what we need to do is to just the first one. We can already get a from the first equation, yeah? From the first equation, you can already get it directly here, that a plus 4 is equal to 3. Therefore, a is equal to 3 minus 4. Our value of a is negative 1. So now that we have a, can we find value of b? Yes, we can. So from the second equation, we know that a minus 2b is equal to 5. Let's substitute for value of a, which is negative 1, minus 2b is equal to 5. So that's going to become negative 2b is going to be equal to 5. You know that negative 1 comes this way, it becomes plus 1. So it is negative 2b, giving us 5 plus 1, which is 6. Divide both sides by negative 2. And what do we have? What we have here is our value of b remaining as negative 3. So a is negative 1, b is negative 3, and that's it. That's the answer. Moving on to part b of the question. Okay. Part b of the question here is that if you know, this matrix is equal to that, determine the values of x and y. Let me write it down here. So part b of the question, 4x 1 negative 1. Okay, like that. Multiply that by x and y. That is equal to 4, 8. So to determine the values of x and y, we are simply going to use matrix multiplication, row by column. Okay. Now I'm assuming here that you know how we do matrix multiplication, how we multiply a row by a column. So that is 4 times x. That's going to become 4x, you know, plus 1 times y, which is y. Then down we have x times x, you know, which is x squared. Okay, plus 1 times y, negative 1 times y, which is negative y. Okay, that is going to be 4, 8. So from there, what we gather here. So from there, what we can gather there is this. What we have is, you know, we have 4x. We have more like two equations. We have 4x plus y is equal to 4. Then we have x squared minus y giving us 8. And all we have to do is, you know, to solve the two simultaneously. So let's try doing so by substitution. Trying to do so by substitution, let me get the second equation here, make y the subject of the formula, and substitute it in the first. So from this second equation, when we make y the subject of the formula, we can already see that y becomes x squared minus 8. So if x squared minus 8, let's substitute that in the first instance, in the first equation. So it means our first equation is going to become, you know, 4x plus y is equal to 4. Now in the place of y, let's put that value of y which we got. So it becomes 4x plus our value of y, which happens to be x squared minus x squared minus 8 is equal to 4. So let's proceed and solve this. So this is going to become 4x, you know, plus x squared minus 8. Let's put this 4 this way. Minus 4 is equal to 0. So this is rearranging it in the form of a quadratic equation, becomes x squared plus 4x minus 12 gives us 0. So from here, let's try and find factorize this. Factorizing this means we are going to find two numbers, one giving us a sum of positive 4 and the other is giving us a product of negative 12. Two numbers, when we multiply them, they give us negative 12. So what are those two numbers? We have 1 times 12, 2 times 6. Okay, 2 times 6 gives us 12. If I make the two negative, negative 2 times 6 gives me negative 12. Negative 2 plus 6 gives me positive 4. So we shall go with these two roots. So this, our next step becomes x squared. Then this middle term is replaced by this 2. So it becomes x squared minus 2x plus 6x. Then we come to minus 12 up here, gives us 0. Then from there we put these in brackets, we factorize them. So what is the common term here? The common term here is an x, so we put x outside the brackets. X into x minus 2, that is plus, what's the common term here? Let's it's actually, let's put minus outside the brackets. No, it's plus 6 into 6x divided by 6 is x, negative 12 divided by 6 is minus 2 is equal to 0. So put the terms that are in the brackets in their own bracket together. So this becomes x minus 2 into, put the terms that are outside the brackets on their own. So the next bracket becomes x plus 6 is equal to 0. So here you can come and say either x minus 2 is equal to 0 or x plus 6 is equal to 0. So from here, our value of x is 2 or our value of x is negative 6. It's one of these two. So now that we have the two values of x, which is x is equal to 2 and x is equal to negative 6. Okay, so what about y? We can get the value of y by substituting in any of those numbers up there. So value of y, let's get the first equation here to substitute for this to get the value of y. 4x plus y is equal to 4. So when we come here and say 4x plus y, 4x plus y is equal to 4. So this is 4 times, let's say when x is 2. When x is 2, so 4 times y, which is 4 times x, which is 2, plus y is equal to 4. 4 times 2 is 8, plus y is equal to 4. So my value of y here is 4 minus 8. And so from 4 minus 8, what do I end up with? Negative 4. And then also, when x is equal to negative 6, what is y? We quote the formula still, and we shall say that 4x plus y is equal to 4. So I'll come here and say 4x plus y is equal to 4. So it is 4 times my value of x, which is negative 6, plus y is equal to 4. So from there, negative 6 is 24. Negative 24 plus y is equal to 4. And then from there, we shall end up with our value of y as 4 plus 24, which is 28. So yeah, those are the various values of x and y. And that, by doing so, we have answered that question. This brings us to the end. This brings us to the end of this video. Thanks for watching. My name is Arnold. This is Kisembo Academy. Take care.